So what can Multispan do for you? Well, I just talked about what we can do for you with the arrestin, but we can do a lot of stuff. We can design an assay for you and develop a cell line for you. All cell lines that are developed come with a recommended assay that we've developed with the assay, because we have to have a partner assay to be able to validate that the cell is what we think is the best cell line. We work directly with our clients when we're developing cells or when we're doing a screen or any of these things. Our turnaround time for running compounds is really fast. If we're doing a secondary screen or a lead optimization program for you, when we get the compounds, we essentially turn them around the same day and you get the data within 24 hours. It's very quick. So all of these different things we can do, so screening, hit confirmation, lead optimization, as well as developing alternate assays if you need them. So we have developed and validated a novel beta-arrestin sensor assay using native or non-tagged GPCR-containing cells. The tool can be attained through license or we can make a cell line for you. We have consistently demonstrated that we can build, Multispan is very consistent. We've demonstrated that we can build stable GPCR cell lines and develop assays using recombinant and native cells. We have the capacity to screen 134 weight plates per week per assay. Here I say our turnaround time is 1 week from receiving compounds to providing data, but we've increased that now, so our turnaround time for standard LO assays that we're getting routinely is 24 hours. Our assays are always run with a QC, must pass specific rigor. The data is presented to the customer as calculated and as raw data. We do that because we like to calculate the data. The customer may want to put their data in their own database and do the calculations themselves, so raw data is provided. And we have almost basically 100% repeat customer rate. People come back to us over and over again to provide them with tools to run their discovery programs. So that is all I'm going to say, and thank you very much for your attention.
Thank you very much, Dr. Miner. We have time for just 2 or 3 questions. Our first question, which arrestins are you using?
So we use arrestin 2 and 3. We use them independently, so it's either arrestin 2 or arrestin 3. And which arrestin we use depends upon what the arrestin pathway is supposed to be for that particular receptor of choice.
All right. Our next question, will this work in primary cells?
And the answer to that is that we're working with partners to actually identify whether the best way to transfect and to put our sensor into primary cells. So essentially, each cell has a different protocol, or each cell type may have a different protocol for transfection. Some may need lipids, some may need different viral particles, and our clients are able to provide us with the best information for how we can package the vectors so that they can actually get them into their cells of choice. And several people are doing pilot screens to identify the exact tools to get it into primary cells to see if it works. We believe that it will work in primary cells, and this is being actively explored.
Okay, good to know. And our final question, which vector are you using, and can we offer choices of vectors?
So we actually do either a bicistronic vector, we have 2 bicistronic vectors, or we can do vectors that are just arrestin on one and then the half arrestin and the membrane tag on the other. The reason we do this is that essentially we want to, and the way that we do this is right now is a lipid transfection protocol. So some people may want to basically optimize the arrestin to the tag on the membrane ratio, in which case I wouldn't want a bicistronic vector. Some people want to be able to have the ratio identical, and so they would want a bicistronic vector. And so that's why we're offering things that way. Eventually what we're going to be doing is having different protocols and different vectors to be able to put for different cell types so that we can say for this cell type, this is what we recommend, this is how you should do it, and this is the viral packaging that we suggest, and whether you do it with a bicistronic or independent vector, that also can be recommended. So this is all being worked out as we speak.